Last problem of the day is problem 5C. So here's a synthesis problem where it looks like we want to do a couple things. We need to turn this alcohol into an aldehyde. We also need to add a couple carbons here and form a ketone. So if I look at the carbons I have in my original molecule, there are 6 of them. Those same 6 carbons seem to line up pretty well with these carbons. So it looks like I'm going to need to form a carbon-carbon bond between those 2 carbons. And that would work well with a Grignard reaction. So if I think backwards about the 2 pieces, it would make sense, since this carbon is attached to an oxygen, to have that top carbon come from a carbonyl. So a carbonyl that looks like this. And then the bottom piece that I circled, that could be my Grignard reagent. NGVR. Now, the Grignard reagent I drew here as I'm thinking backwards, this wouldn't be possible because I can't have an aldehyde on my Grignard reagent. Aldehydes react with Grignards. So maybe that aldehyde comes in after I do the Grignard reaction. But that's something that we can think about as we think about order of steps. The main thing is that if I look at the molecule I'm starting with here, I have an OH on my molecule. I can eventually turn that into an aldehyde. But again, I don't want to form a Grignard reagent in the presence of an alcohol. It will deprotonate the alcohol and ruin the Grignard. So the first thing I'm going to do is to protect my alcohol. So TMS chloride with a little triethylamine. That's going to turn my OH into an O-TMS group. Now I can think about turning this into a Grignard reagent. And right now I have a double bond here. So I have to think about all the things I can add across a double bond. And specifically, I want the thing that I'm adding to end up on the anti-Markovnikov position. So I don't have too many reactions that do that, but one that would work great is to use HBr and throw in some peroxide to make sure that the bromine adds to the less substituted carbon. A bromine makes sense here because then I can easily turn it into a Grignard reagent. Okay, so this is going to put a bromine here. I still have my protected alcohol. And now when I add magnesium, I'm going to form that species. Okay, next I can do my Grignard reaction, and we decided that we were going to use a little carbonyl compound that looks like this. So I'll throw in this aldehyde, and then always work up my Grignard reaction with water. And at this point, when the Grignard reagent adds, it's going to turn this into an alcohol. So I'll have an OH there, and I still have my protected alcohol down at the bottom, O-TMS. Okay, so we're getting close. So we have to do a couple things. We're going to have to turn this OH into a ketone. 1 bond to oxygen going to 2 bonds to oxygen looks like an oxidation reaction. I also need to deprotect this alcohol and turn it into an aldehyde. So again, after the deprotection, I'm going to need to do an oxidation reaction. And both oxidation reactions, I have to be careful about the oxidizing agent because this will be a primary alcohol going to just an aldehyde. So I have to use a mild oxidizing reagent for that. But the same mild oxidizing agent will turn a secondary alcohol into a ketone. So I can do all of my oxidations in one step, which is going to save time in a synthesis problem, if I first deprotect this alcohol. It would take longer to oxidize this, deprotect this one, and then oxidize this one separately. So I'm going to do my deprotection step next. And we've got to make a little room here somewhere. Let's think about how we're going to do this. I guess we're going to let's erase some of the top stuff here. Okay, so my deprotection, I'm going to use TBAF. That removes a TMS protecting group. So I have this alcohol at the top, but now this becomes an alcohol on the right side. And now finally, to get to the final product, the only thing I need to be careful about is the fact that I have a primary alcohol and I want it to turn into just an aldehyde. I do not want it to get oxidized all the way to a carboxylic acid. So the best choice of reagent here is going to be PCC, or you could do a Swern oxidation, or you could do a Dess-Martin oxidation, whichever your favorite mild oxidizing agent is that you want to use. Okay, so there's the rest of that problem. If you want to try more synthesis problems, there were some synthesis problems on the last page of the previous worksheet, the one that had said alcohols at the top. And then in addition to that, if you go on Canvas, I'll post another worksheet that says synthesis practice problems alcohols. So you can get yourself a copy of that, and then there are a whole series of synthesis problems, some which are really long. So this is great practice for the quiz that's coming up on Tuesday.